You know, for the longest time, the world of AI has felt like this classic David and Goliath story, right? You've got these massive proprietary models from the tech giants, and then you have the scrappy open source community. But what if David just got a brand new high-tech slingshot? Well, today we're diving into a paper that might just change the entire game. So, the researchers over at DeepSeek AI started with a really important question, a really fundamental one. Is that gap in power between open source and the big closed source models, is it getting smaller or is it actually getting bigger? And while the answer they found, it wasn't just a little worrying. It was a massive wake-up call for the entire open source world. I mean, don't get me wrong, open source models are definitely getting better. But the problem is the proprietary models with all their resources are accelerating at this just breakneck pace. So that gap, it wasn't just growing, it was turning into a full-blown chasm. And that's when the team decided, okay, we need to figure out exactly why this is happening. And what they found was fascinating. Their investigation pointed to three, let's call them hurdles, three critical flaws that were holding back pretty much all open source models, especially when you ask them to do really complex, heavy-duty reasoning. So let's dive in and break down what they found. Okay, so hurdle number one, their core architecture was just inefficient. It was burning through way too much computing power, especially when dealing with the long, complex documents that are, a huge part of AI tasks these days. Number two, they just weren't getting enough post-training. Think of it like this. They were smart, for sure, but they weren't wise yet. They hadn't been pushed to their limits. And third, and this is a big one, their ability to be intelligent agents, to actually use tools and solve problems step by step, it was seriously behind. And look, these weren't just small tweaks that were needed, these were fundamental roadblocks. And these are the exact problems DeepSeek decided to tackle. So, okay, that's the diagnosis. What's the cure? Well, how did they do it? They came up with DeepSeek V3.2, a brand new model built around a really clever three-part solution. And the best part is, each piece of their solution was designed to be a direct counter to one of those big weaknesses we just talked about. So remember that inefficient architecture? To fix that, they came up with something called DeepSeek Sparse Attention, or DSA for short. That post-training problem? They solved that with a brand new scalable reinforcement learning framework. And to get those agent skills up to snuff, they built a whole pipeline for what they call large-scale agent synthesis. I mean, it's just incredibly elegant, right? A one-to-one solution for each problem. It's a perfect example of really targeted, smart innovation. All right, let's talk about that first one, DeepSeek Sparse Attention. What is that? Okay, think of it like this. Most older models use a giant floodlight. They try to pay attention to every single word that came before in a document. It works, but man, is it expensive computationally. DSA, on the other hand, is like a smart spotlight. It intelligently focuses only on the words that actually matter for the task at hand. And the result of that clever switch? Well, the result is a massive drop in cost. Just look at this. Compared to its predecessor, V3.1, the new model, V3.2, is just dramatically cheaper to run. And that's especially true when you're feeding it those really long documents. We're talking about efficiency you can literally see on the balance sheet. It's a huge deal. Okay, so next up, that post-training problem. I love this analogy. If the initial pre-training is like general schooling for the AI, this new reinforcement learning phase is like an intense Olympic-level training camp. It's all about pushing the AI to its absolute limits, throwing the hardest possible reasoning tasks at it to unlock abilities that were just lying dormant before. And when I say intense, I mean it. They did not hold back. Get this, they dedicated a computational budget for just this post-training phase that was more than 10% of the entire cost of the initial training. That is a massive, massive bet on the power of refinement. And finally, we've got those agent skills. So what does a complex agent task even look like in the real world? Well, here's a perfect example. This isn't just asking a simple question, right? This is a whole multi-step planning problem. You've got tricky constraints like budget, hotel ratings, locations. To solve something like this, an AI can't just talk. It has to do stuff. It needs to use tools, search for information, and actually make decisions along the way. So how do you teach an AI to do all that? Well, they didn't just give it a textbook. They basically built an entire world for it to learn in. They created specialized agents, one for searching, one for coding, one for interpreting that code, and then for everything else, they synthesized, get this, Over 1,800 different virtual environments, packed with 85,000 complex problems. I mean, this is how you don't just teach an AI, you basically raise a truly capable assistant. Okay, so they diagnosed the problem, they engineered these really elegant solutions. But the billion-dollar question, the one we all want to know, is, did it actually work? How does this new DeepSeek V3.2 really stack up against the best of the best? Well, the results are honestly a total game changer. Across a whole suite of benchmarks, we're talking reasoning, coding, math, the standard DeepSeek V3.2 goes toe-to-toe with the giants. We're talking GPT-5, Kimi K2. It didn't just narrow the gap. In a lot of these tasks, it completely erased it.
But you know what? The team didn't stop there. They basically asked themselves, okay, what happens if we just take off the training wheels completely? And so they created this special experimental version called DeepSeek V3.2 Speciale. They trained it exclusively on the hardest, gnarliest reasoning data they had, just to see how far an open source model could really be pushed.
And the results of that experiment are an absolute bombshell. This special version doesn't just compete with the top proprietary models, it actually surpasses them. I mean, just look at these scores. It's outperforming models like Gemini 3.0 Pro, which was pretty much the undisputed king of reasoning, in some of the toughest math competitions on the planet. And all of that leads to this. This right here is probably the single most impressive achievement in the entire paper. This isn't just another number on a chart. We are talking about a gold medal on the world stage. So what does that mean? It means DeepSeek V3.2-Special achieved gold medal level performance in some of the world's most prestigious competitions for both math and computer science. We're talking about the International Mathematical Olympiad, the ICPC World Finals. These are the big leagues. This is an absolutely incredible milestone for any AI, let alone one that's open to the entire world. Okay, let's take a step back and zoom out for a second. A powerful new model is, of course, really exciting. But what are the bigger implications here? Why is this such a huge deal for the future of AI? Here's the bottom line. What this all really means is that DeepSeek V3.2 proves, without a doubt, that open source AI can compete at the absolute frontier. It shows there's a path to top-tier performance that's also computationally efficient. It dramatically narrows that gap we talked about between open and closed models, and it sets a whole new standard for what accessible, powerful AI can be. Now, to be fair, the paper is really honest about the model's limitations, which is great to see. Compared to the absolute biggest frontier models out there, DeepSeek V3.2 still has less broad world knowledge, and it also tends to be a little bit more verbose. It uses more words or tokens to get to its answers. So that race for what you might call intelligence density is definitely far from over. But that leaves us with this final, really exciting question. For so long, the story has been that only trillion-dollar companies could build this kind of frontier AI. This paper doesn't just challenge that story, it completely shatters it. So think about it. If one dedicated open-source team can build a model that wins gold medals on the world stage, what does that mean for the future of powerful AI that's accessible to everyone? The game, my friends, has well and truly changed.